So 3.2, analyzing forces in circular motion. Now, you know the total force is equal to MA. Centripetal acceleration is V power 2 over R, right? M multiplied by N of the A, we put V power 2 over R. Total forces combined, it will give you what? The centripetal, all of the forces provide the centripetal force. Acceleration, sorry. Yeah. Now, look at this question. A car of mass 1.1 10 power 3 kilogram negotiate a level curve at a constant speed 22 meters per second. The radius of the curve is 85 meters. So draw the FP diagram of the car named provide the centripetal acceleration. Determine the magnitude of force named that must be exerted to keep the car from speeding. So this is what we have. You have a normal force, you have an upward, you have a gravitational force mg. There is a frictional force that avoid your car to moved out of the curve. So just imagine you're sitting in a car, your car going on there, you're reaching a curve, so your car turning. What do you feel? You feel you moved out of the curve, right? You just feel it. You just become like that. You feel a force push you away from the curve. What's holding you in that curve? Friction. How do I know it? Just imagine if you're moving in the curve with the same speed in a sunny day and a snowy day. Of course, in a snowy day, you move with the same speed, your car might slide out of the curve, right? Because there's less friction. There is less friction. So what you're holding you there is friction. That's why friction is toward center, push you like that to cancel the centripetal force that push you away. Anyway, so you want to find that force. Total force in X direction. Total force is going to be M V2R. So this is in X direction because your circle is here, your center force is that. This one should be force of friction, static friction. Why is static? Because your distance to the center will not change. It's all, you're moving in a circle, right? You're moving in a circle. You're here, and a second later, you're here. Your distance to the center will not change because this is a circle. So always the radius is the same. That's why you're not moving out of the curve, right? So this is going to be the same. So it's going to be static. So you have a mass of the car, you have a velocity of the car, you have a radius of this curve. You can find a static friction. Static friction. Okay. Determine the minimum coefficient of the static friction needed to keep the car on the road. So since we know that force F of S is equal to mu S F of N, and I know F of N is mg, right? So it's going to be mu S mg. I just isolate for mu S, so it's going to be F of S divided by mg. We got F of S from the previous step, and we go like g here. So mu S is going to be 0.58. Now here is a car, it's moving in a curve. The mass of the curve is given, the curve, the R is given, and the angles, the banking curve is given. What force provides the centripetal force? Okay, let's just draw that. So here is the picture. This is the car. You know that this is your F of G toward the S. f of t. You have force of normal. Of course, you have frictional friction. This friction will be here because the centripetal will push your object out. The friction will be here. Okay. Let's say you have frictionless exertion. Here is frictionless. Sorry, I'm going to erase that. So it's frictionless. So what's providing you from sliding out of this? So what I do, I consider the x-axis. Let me just to put the theta here. The angle, we have the angle theta there. I put my x-axis to be this. Why I do that? Because the centripetal force, just imagine this is around here. Centripetal force is going to be this way toward the center of your head. The center of your curve is here, basically. Imagine it's circle, the center is here. It's convenient that I take this to be x-axis and this one to be y-axis. Okay. So if this is theta, according to Z pattern, this going to be theta as well, right? So Z pattern here, so this will be theta. Also, you note that f of n making 90 degree with the surface. So that one, this one from here to be 90 minus theta. So therefore this, I'm just gonna do it. So this is 90 minus theta. Also, this whole thing is again 90 degrees, so this will be theta. I'm gonna do it with the red. This will be theta. Okay. Now, I'm gonna find the x and y component of the f of n, right? F of n in x direction is opposite. Opposite is sine. It's gonna be f of n sine theta. And I need to find a y component. So y component is gonna be adjacent. F of n in y direction gonna be f of n cosine theta. Okay, since your object is not moving up and down, your total force in y direction need to be 0. And total force, because you have acceleration, centripetal acceleration. Total force in x direction is gonna be mv2r, right? So I'm doing first that one. I just have x direction in this way. I have f of n sine theta. Oh, sorry, this is x direction, my bad. We're doing the y direction first. So in y direction, we have two forces. F of n sine theta, which is positive, minus, here f of g is mg, minus mg. From that, I can rearrange for f of n. F of n, if I rearrange it, so mg to the other side, and I'm divide both sides by sine theta. So this is going to be my f of n. Now here in x direction, I just have f of n in x direction is here, is f of n sine theta. Did I use that wrongly? Yeah, this is cosine, guys. This is y direction. Let me just correct that. This is cosine theta. Yeah, I'm doing y direction, so this is y direction. It's gonna be cosine theta. Here, I have f of n in x direction is f of n sine theta. Is equal to what? Mv to r. Instead of f of n, I can use that mg cosine theta. So it's mg cosine theta equal to mv to r. Mass and mass cancel from both sides. Sine over cosine is tangent. I'm looking for a speed, right? So v is equal to r to the other side. It's going to be r g tangent. See, sine over cosine is tan. And since it's power 2, so I'm just taking a square root of that. So we have r, which is 85. We have g, which is 9.8. And we have theta, which is 19 degrees. As we see that here. So this is independent of the mass of the object. Now let me just erase this. Here is another example. A 3.5 kilogram steel ball in a structure engineer wraps swing at the end of the rigid steel rod at a constant speed vertical radius flow. So R is given 1.2, frequency 1 hertz. So from frequency, I can find the acceleration, the acceleration. Calculate the magnitude of the tension the rod due to the mass of the top is at the A and B at the bottom. We want to find the tension when the object is at the top. So see, this is the picture. If this is the rod and the object is there, of course, tension is out of the object toward the root. So this is F of t, right? Also, there is another force of gravity, F of t. These two forces is providing centripetal force. So it's both down. And you know, because the downward is toward the center, I take down to be positive. So down, for me, down is positive. So what we do, we say f of t plus m of g, because both down is positive, is equal to mac. Instead of ac, I put 4 pi to rf, because the frequency is given. That's one of those questions for ac. Arrange for f of t. We have everything, we just set the values to find the force of tension. Now the second part is when the ball is moving at the lowest point. Just making another picture. So here is when it's the ball is here. You know, f of t upward toward out of the object toward the rope, and we have f of t. Since toward the center is up, I put the upward positive, like toward the center is positive. So total force, f of t is positive, f of g is negative. So it's f of t minus m of g is equal to mac, and again, instead of ac, I put 4 pi 2 or f power 2. They have frequency. So you just rearrange it for f of t. Comparing these two, you see that f of t tension in the previous one is much more lower than here. Because now you need to tolerate the mass as well, right? So here is a roller coaster. Then an object is there on a roller coaster. Which but we have f of n and we have m of g, which both of them, I think this is that. A circle used almost century ago. Okay, with this design, however, the coaster had to be fast. Just want to see which. Okay, I'm just encouraging a student to read these two examples for yourself and do question number 1. This is page 132. Also, question number 3, 4, and 5 you can do. Page 133. And here is, you don't have to do this. We're done.